The ninth question that we have, it has been given that element crystallizes in face-centered cubic lattice having edge length 400 picometers. We need to calculate the maximum diameter of an atom which can be inserted in a space inside without distorting the structure. So we know that FCC has two types of voids, that is tetrahedral and octahedral voids. Now for the maximum diameter, we know that octahedral voids are larger in size than tetrahedral voids. Therefore, the largest size of the atom which can be inserted will definitely be inserted in octahedral voids. Therefore, we need to find out the maximum size of the atom which can be inserted in the octahedral void. Now we know that the octahedral void is formed such that the octahedral void can be visualized in this fashion. It is actually formed when three closed pack atoms are like this, and on top of this three more atoms are put in. So it is actually formed by the combination of these two layers, and it can be visualized in this fashion also. This is the octahedral void, and the maximum radius of the atom which can be put here is equal to r. Let that be equal to r. Therefore we can clearly see over here. Let us join this. This is equal to capital R, that is the radius of the atom. Now we can see clearly by Pythagoras theorem that 2 times r plus r whole square is equal to 2r whole square plus 2r whole square, that is equal to 8r square. Therefore 2 times r plus r is equal to 2 root 2 times r. Therefore we get that 2 times small r is equal to 2 times root 2 minus 1 into capital R, that is small r is equal to root 2 minus 1 into capital R, that is equal to 0.414 into capital R. That is given to be equal to, we need to find out that since the edge length is given to be 400 picometers for FCC lattice, we know that the face of an FCC lattice is something like this. So we know that this is equal to 4r and this is equal to root 2a. Therefore root 2a is equal to 4r for FCC. Also remember this. Therefore using this we can find out r, which is the radius of the atom. R is equal to root 2 upon 4 into a. Therefore we can write over here root 2 minus 1 into root 2 upon 4 into a, which is given to be 400 picometers. So on calculation this will give 58.6 picometers. Now we need to find out the maximum diameter of the atom which can be placed. That will be just 2 times of this. That will come out to be 117.2 picometers. So final answer for the maximum diameter of atom which can be placed in the void comes out to be equal to 117.2 picometers. So the important thing you should learn from this question is that the octahedral void, the maximum radius of the atom which can be placed in an octahedral void comes out to be equal to root 2 minus 1 into the radius of the atom, and for a tetrahedral void it is equal to 0.225 into r. Remember both of these, and by comparison we can obviously see that this is equal to 0.414, and therefore the radius of the atom which can be inserted in the octahedral void is greater than that of the tetrahedral void.